Imagine standing on the edge of a new era, where humanity reaches out to touch the stars once more. In 2025, NASA's Artemis 2 mission will do just that, carrying astronauts on the first crewed journey to the moon in over half a century. This isn't just a trip around the block. It's a bold leap toward a future where humans live and work beyond Earth. Let's dive into why Artemis 2 is one of the most exciting moments in space exploration and what it means for our planet's cosmic ambitions. The Artemis program, named after the Greek goddess of the moon, is NASA's vision to establish a sustainable human presence on the lunar surface by the end of this decade. Artemis 2 is the critical second step. Following the uncrewed Artemis I, which successfully tested the Space Launch System and Orion spacecraft in 2022, Artemis 2 will send 4 astronauts on a 10-day mission to loop around the moon and return to Earth. This flyby, set for late 2025, won't involve a landing, but it's a pivotal test of the systems needed for Artemis 3, which aims to put boots on the lunar soil as early as 2026. The mission builds on decades of technological advancements, pushing the boundaries of what's possible in deep space exploration. So who are these astronauts? The crew includes 3 Americans and 1 Canadian, a nod to the international collaboration driving this mission. Reed Wiseman, a seasoned NASA astronaut, will lead as commander, joined by pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen. This diverse team reflects the global effort behind Artemis, with Canada's contribution highlighting the mission's cooperative spirit. Each astronaut brings unique expertise, from engineering to scientific research, ensuring the mission's success in the harsh environment of deep space. Their training, conducted in advanced simulators and mock-up spacecraft, prepares them for the challenges of navigating thousands of miles beyond Earth's protective magnetic field. Now, let's talk about the tech making this possible. At the heart of Artemis 2 is the Orion spacecraft, a marvel of modern engineering. Orion is built to carry humans farther than any spacecraft before, designed to withstand the intense radiation of deep space and the fiery re-entry into Earth's atmosphere at 25,000 miles per hour. Its service module, provided by the European Space Agency, is a critical component, supplying power, propulsion, and life support. This collaboration with ESA, involving Germany and other European nations, underscores the mission's international scope. Germany's aerospace industry, for instance, contributes key technologies to the service module, making this a point of pride for European viewers. The service module's solar arrays, capable of generating enough power to run 2 households, are a testament to the precision engineering required for deep space travel. The Space Launch System, or SLS, is another star of the show. This colossal rocket, the most powerful ever built by NASA, stands taller than the Statue of Liberty and can hurl Orion toward the moon with unmatched force. During Artemis 2, the SLS will launch the crew from Kennedy Space Center in Florida, propelling them into a high Earth orbit before slingshotting them toward the moon. The mission's trajectory is a carefully choreographed dance. The spacecraft will swing around the moon's far side, coming within 4,600 miles of its surface, before using lunar gravity to catapult back to Earth. This path tests Orion's navigation and communication systems in deep space, far beyond the reach of GPS or standard radio signals. The precision required is staggering. Engineers must account for variables like solar radiation and gravitational perturbations to ensure a safe return. Why does this matter? Artemis 2 isn't just about circling the moon. It's about proving we can live beyond our planet. The mission will gather data on how humans fare in deep space, from radiation exposure to psychological challenges in a confined spacecraft. These insights are crucial for future missions to the Moon and Mars. Artemis 2 also sets the stage for a lunar gateway, a small space station orbiting the Moon, where astronauts will stage future landings. This gateway, another international project, will be a hub for scientific research, testing technologies for sustainable living in space. By studying the Moon's environment, Artemis 2 will help scientists understand how to protect astronauts from cosmic rays and develop life support systems for long-duration missions. The broader impact of Artemis 2 is profound. It's a symbol of human ambition, uniting nations in a shared goal. The mission's success could inspire a new generation of scientists, engineers, and explorers, much like Apollo did in the 1960s and 70s. Economically, the Artemis program is expected to create thousands of jobs, from aerospace engineers in Germany to technicians in the U.S. Scientifically, it will deepen our understanding of the moon's geology and resources, like water ice, which could fuel future missions or even support lunar habitats. Water ice, found in permanently shadowed craters, could be converted into drinking water, oxygen, or even rocket fuel, making the moon a stepping stone for deeper space exploration. But it's not without challenges. Artemis 2's timeline has faced delays due to technical hurdles and the sheer complexity of deep space travel. The SLS rocket and Orion spacecraft must perform flawlessly, and engineers are working tirelessly to ensure safety. The mission's cost, estimated at over $4 billion, has sparked debate, but supporters argue it's an investment in humanity's future. After all, the Apollo program cost billions too, yet it gave us technologies like GPS and advanced computing that shape our lives today. The rigorous testing of Artemis 2 systems, from thermal shields to propulsion, reflects NASA's commitment to safety, ensuring the crew returns home unscathed. Beyond technology and economics, Artemis 2 carries a profound scientific mission. The crew will conduct experiments to study the effects of deep space radiation on human biology, using advanced sensors to measure cosmic ray exposure. These findings will inform future missions, helping scientists develop shielding technologies to protect astronauts on long journeys to Mars. The mission will also test new communication systems, like laser-based links, which offer faster data transfer than traditional radio signals. These experiments are critical for building the infrastructure needed for a sustained human presence on the moon, including the potential for lunar observatories to study distant galaxies. The international collaboration behind Artemis 2 extends beyond ESA and Canada. Partners like Japan's JAXA and Australia's Space Agency are contributing expertise and technology, making this a truly global endeavor. For instance, JAXA is developing components for the Lunar Gateway, while Australian engineers are aiding in communication systems. This cooperation not only pools resources, but also fosters a shared vision for humanity's future in space. For viewers in Germany, the involvement of local companies like Airbus, which builds parts of the Orion service module, highlights the mission's relevance to European innovation and pride. Artemis 2 also offers unique opportunities for public engagement. NASA has launched initiatives like the Send Your Name to the Moon campaign, allowing people worldwide to have their names etched on a microchip aboard Orion. Schools and universities are being invited to participate in virtual mission control programs, where students can track the mission's progress in real time. These efforts aim to make Artemis 2 a shared experience, inspiring young minds to dream of careers in space exploration. Imagine the excitement of knowing your name is orbiting the moon or watching live data from a spacecraft millions of miles away. It's a chance to feel part of history. As we look to 2025, Artemis 2 stands as a testament to what humans can achieve when we work together. It's a bridge between the Apollo era's legacy and a future where the moon is a stepping stone to Mars and beyond. Imagine the view from Orion's windows, the moon's cratered surface up close, Earth a fragile blue marble in the distance. It's a moment that will remind us how small our world is and how vast our potential. So, as the countdown to Artemis 2 begins, ask yourself, what does it mean to reach for the stars? Stay tuned, because this is just the beginning of our journey back to the moon.